Welcome to The Explainer. Today we're doing something a little different. We're going behind the scenes, digging into the private work logs of a developer to uncover the hidden, complex work that's required to build trust on the internet. So, we're about to piece together a kind of digital detective story. And our clues? Well, they're not fingerprints or anything like that. They're command line outputs, weird error messages, and private notes. And together, they're going to reveal why the invisible foundations of the web matter more than ever. Our whole investigation, it all starts with this single domain. On the surface, perforito.us, it looks perfectly fine. But underneath, a really critical piece of its security was broken. And check this out. The developer's own logs show this dramatic shift in just 11 days. On June 18th, a security audit basically comes back saying, nope, nothing here. It's missing what's called a DS record, a key security component. But then, by June 29th, boom, it has two. Figuring out that small change, well, that's the key to this whole story. So back on June 18th, while the domain was live, it was missing this crucial security feature called DNSSEC. You can think of it like a website missing its tamper-proof seal. It just leaves it vulnerable, wide open to an attack. So what is DNSSEC? Essentially, it's the thing that guarantees that when you type in a web address, you're actually taking to the real website and not some malicious copy that's designed to steal your information. It's a foundational layer of trust for, the entire internet. So, seeing this vulnerability, the developer tries to activate DNSSEC, but something went wrong. Instead of a confirmation, they were hit with this cryptic error message. And that's our central clue. This error message, pulled directly from the logs, is the heart of the mystery. It's basically saying that a digital signature, an RSIG, was missing. Now, that signature is supposed to act as a guarantee, proving that the website's security key is authentic. Without it, the system just can't trust the key. And the investigation revealed this critical inconsistency. See, the domain told the world it was secured by two keys, kind of like a bank vault that needs two different keys to open. But in reality, only one of those keys was actually working. The other one was there, but it was silent. This mismatch broke the digital chain of trust, and that made the whole system insecure. So, how do you fix an invisible error like this one? The developer's logs lay out the entire timeline of how this digital puzzle was finally put together and solved. And this was not a quick fix. After that initial failure, the developers spent days troubleshooting. Then on June 29th, they changed the name servers, they performed what's called a key rotation to reset the digital signatures, and finally, late that night, the validation worked. The chain of trust was repaired. So, with the domain security finally fixed, we can now get to the real reason for all this painstaking work. You see, it was never just about one website. I mean, why would a developer spend days fixing such a complex, hidden security flaw on just a single domain? Well, it's because that domain was meant to be a bridge. The real goal was to connect the traditional web, what we call Web 2, to the decentralized world of Web 3. And to do that, that foundation of trust, that DNSSEC, it had to be perfect. The developer was using something called the Ethereum Name Service, or ENS. It works a lot like the web's address book, but instead of pointing domain names to IP addresses, it points human-friendly names to those really complex blockchain wallet addresses. And the actual connection? It was made with this single line of code. By adding this simple text record to the domain's settings, the developer created a permanent, verifiable link pointing perforito.us to the blockchain identity nurture.ease. And this triumphant message from the developer's log, it just says it all. The bridge was built, the traditional domain and the new blockchain identity were now securely linked, and it was all thanks to that initial, difficult security fix. But our story doesn't end there. This single domain fix was just one small piece of a much larger, more ambitious blueprint. When we dug a little deeper into the developer's notes, we found the name of the whole project, the Credential Vault. This whole exercise was a proof of concept for a new way to manage our digital identities securely. So the Vault's blueprint combines three core technologies. First, you've got blockchain for that unchangeable public ledger. Second, proof of work. Yep, the same security model as Bitcoin to prevent unauthorized changes. And finally, strong encryption to keep all the user's private data completely private. So what's the big takeaway after diving this deep into one developer's private logs? Why does all this invisible work really matter? Well, first, it reveals the hidden complexity. This connection was labeled gasless, meaning it was free for the end user. But behind the scenes, it still required at least 3 separate, paid transactions on the blockchain to make it permanent. A good reminder that nothing is ever truly free. But more importantly, it shows that the trust we place in the digital world isn't magic. It's built, piece by painstaking piece, by people working on complex, foundational infrastructure that most of us will never even see. It's the unseen scaffolding holding everything up. And that leaves us with a really critical question. As our lives, our finances, and our very identities become more and more digital, the strength of that foundation is everything. So who do you trust to build it?